On the 11th of January 2003, a regional plume of methane was observed on Mars by an Earth-based telescopic observation. An accumulation of lines of evidence has led to the hypothesis that this methane plume arose from an intense meteor outburst arising from Mars crossing Comet C2007 H2 Skiff at the same latitude, shortly prior to the observation. Methane from meteor showers does not come from direct deposition of gas from the cometary material, but from ultraviolet irradiation of dust and meteoritic material after it fragments in the Martian atmosphere. This process is very fast and would liberate methane on the timescale of the methane observed in the 2003 event. For the meteor origin hypothesis, a literature search for Mars-crossing comets interacting close to the 2003 event produced Comet H2 Skiff. This comet's closest orbital interaction occurred only 3 sols prior to the 2003 event. Even more interestingly, the cometary debris in H2 Skiff's orbit is concentrated towards one side of its orbital track in relatively high-density clumps. This means that strong outbursts are possible late in its interaction with Mars, within the 3-sol period. H2 Skiff was also identified as the most likely Mars-crossing comet to produce strong meteor showers and meteor outbursts on Mars. A study of the 2003 event by Miskna and co-authors indicated that the methane must have been generated nearly instantaneously over about 80 degrees of latitude, no more than 1 or 2 sols prior to the spectroscopic detection. A meteor shower from H2 Skiff would meet all of these requirements. So H2 Skiff may generate strong meteor outbursts, but would a meteor outburst fall at the site of the 2003 plume? Analysis of the orbital geometry indicates that a meteor shower from H2 Skiff would have a radiant in the minor constellation Microscopium, and so would be called the microscopids. Assuming a typical meteor outburst length of an hour and coinciding outburst timing, the 2003 methane plume would lie within the footprint of a microscopic meteor outburst. The total mass required is difficult to explain, however. The paper describing the 2003 event calculates total methane of 19,000 tons. A meteor shower would have to drop on the order of 800,000 tons of material into Mars' atmosphere. This is an extraordinary amount of mass that is difficult to reconcile. However, there are possible mitigating factors. The 2003 event methane calculations have been challenged in 2 separate papers. One disagreed on the grounds that Martian atmospheric chemistry is inconsistent with presence of large amounts of methane. The second pointed out that the spectroscopic absorption feature used to measure the methane is actually overlain by a line for the terrestrial 13C isotope of methane. Also, additional methane lines in the original data do not record a large amount of methane. This paper concludes that less than 3 parts per billion of methane were observed and that the total mass was also much lower. Also, the orbit of Comet H2 Skiff suggests that it may harbor large amounts of debris. Skiff's orbit passes close to both Mars and Saturn's orbits, indicating that the comet could not persist in this orbit for very long. Therefore, it may have recently been perturbed into its present orbit. That perturbation may have generated debris, and that debris may accommodate large meteor outbursts. When all of these factors are considered, the possibility exists that Comet H2 Skiff may have generated a strong meteor outburst shortly before the 2003 methane detection. That outburst would have covered an area on Mars consistent with the observed plume, and could have quickly generated methane over a very large area, just as is required to explain the size and shape of the observed plume. The total mass required is problematic, but might be resolved by the mitigating factors we have already discussed. In total, the hypothesis of a meteor outburst origin for the 2003 methane event is compelling and merits further investigation. Understanding the origin of the 2003 methane plume is important to the search for life on Mars, even if it turns out to originate from an abiogenic source. This is because, In order to identify any potential biological methane on Mars, we must first identify and quantify the non-biological sources which exist. Thank you for your attention.